Okay, continuing with the paper 2, this is question 10. In a race, boats sail around 3 buoys, represented by A, B and C, in the diagram below. And they give information here that you can see on the diagram there. B is 8 from A, on a bearing of 060, okay, and C is 11 from B, so there we have it there, and you have 13 there. Calculate the size of angle ABC. A to B to C, we want that angle there. And this is it's a cosine rule question, but it's the cosine rule formula where you find the size of the angle. The cos of B is, you take the two sides, either side first. 8 squared plus 11 squared, take away 13 squared, over 2 times 8 times 11. So just repeating that. 8 squared plus 11 squared, take away 13 squared, the far away 1 squared, over 2 times 8 times 11. So, calculator gives 16, calculator gives 176. Divide it out, and you get 0.091. And you don't want cos B, you want B, so do a shift cos on your calculator. Make sure you're on degree mode, 84.8. So, A to B to C is 84.8. So that's 84.8. Hence find the size of the shaded angle. Okay. If I can just draw you back to this bit here. If that's 60 degrees there, then that's 60 as well. And if that's 60, then that's 120. And now that we've got that to be 120, we know that that's 84.8. We can now get that one there. So the shaded angle is 360, take away 84.8, take away the 120 we got a wee second ago, and that's 155.2 degrees. Question 11 is a changing subject of a formula. S equals ut plus a half at squared. Those of you who do physics might actually recognise that formula. Okay, we want it changed to A, so we want to move everything from there over to the other side algebraically and be left with A. The very first thing you do is you move over things that are not within the kind of big blob that I call it, that A's at. So remember the rules, you move it over, you change the sign, that's positive ut, that's take ut, so that's your first step. Okay, so we've now got a half at squared. If things are in one big mass, then things move diagonally like that. 2 goes up to there, and the t squared goes down. So the 2 goes up, put that in a bracket, times by 2, that's how you write that. 2 times st ut, put that in a bracket, take the t squared down, so it's 2 times st ut over t squared, and that's A. Question 12. Solve the equation 11 cos x take 2 equals 3 within the range of 0 to 360. Okay, there it is there. We want to get to cos x, so we have to move over the take 2, that becomes a plus 2. 11 cos x is 5, divide by 11, and you get 0.455. So cos of x is 0.455. Do a shift cos, and you get 62.9. But be aware that there's another angle there. If I do obviously it was a very poor cos curve, but there it is there. You can see that if that is 0.455, then there's one solution here, and that's the 62.9, but there's another one over here, and that's 360 take 62.9, 297.1. There it is there. Use your calculator, of course. And the last question, here we go, question 13. The circle shows the entrance to a tunnel which is in the shape of a circle, part of a circle. And you can see the diagram there. The diagram below represents the cross section of the circle. The centre of the circle is O, and then you have an angle of 50 degrees. The radius of the circle is 7. Okay, you can see it all in the diagram there. Calculate the area of the cross section of the circle. What you have here is you have a triangle with 50 degrees, 7 and 7. We can use a half AB sine C for that one. And we have 310 degrees worth of a sector of a circle of radius 7. So there we have it there. The cross section is the sector of a circle plus the area of the triangle that I just talked about. Okay, area of a circle, pi r squared. Pi times 7 squared would give that. We're at a whole circle. It's only 310 degrees worth out of the 360. So I tend to divide by 360 times by 310. You can see the fraction there, and that's what my calculator gave me. The area of the triangle is a half of that times the sine of the angle in between. Again, there we have it there, calculator on degree mode. Add them together and you get the total area of the cross section is 151.4 square metres. And that's the end.